Good evening. My name is Daniel Karengera, and I'm going to discuss on how we can apply serverless architecture to the Algonquin pet store that was used in the previous semester. So first, let me give a brief overview of what the Algonquin pet store application is. So the Algonquin pet store application is a containerized microservice solution which is deployed on Azure Kubernetes service, and it is made of different services that were developed using different programming languages such as Node.js, Rust, Go, and Python. So the key components of the Algonquin Pet Store application are the storefront, store admin services, which are used for customers and staff user interface, and the order service, which is used to post orders to the queue, and then the product service, which is used to manage the product catalog. So the other service is the makeline service, which is used to process the orders and then store them to a MongoDB database for persistent storage. And then the other service is the AI service that uses OpenAI and DALL-E3 to generate description and images of the products. And other components are a message broker, which is RabbitMQ, and there are also two virtual customer and virtual worker, which were used to simulate order workflows. So when transitioning from the previous architecture to the serverless architecture, the services which could be converted to Azure functions, I figured that they would be the order service, makeline service, and AI service. So the order service, it would be converted to an HTTP triggered Azure function. And the reason why I picked to use HTTP triggered Azure function is that the order service doesn't need to run all the time. So by converting the service to an Azure function, this would help to make the service more cost efficient because it would only be running when it's needed. So the same for makeline service. So this would be converted into a queue-triggered Azure function, meaning that it would be consuming the orders from the queue, whether it's Azure Service Bus or Azure Storage queue. It would be triggered by the messages from the queue, and then it would process the orders and then store them to a persistent storage like MongoDB or Cosmos DB. So for the AI service, I chose to migrate this to an Azure durable function, so that we could be able to handle the failure of the image generation, which is which could be a long running function. For the feature that could be converted to logic apps is to monitor the product catalog. In case, for instance, there are shortages on some products, so we could use a logic app to send notification to the admin to let them know that there are some products that are having shortages, or also if there are orders which are failing, or when there are many orders that are being processed. This could also benefit from a logic app by creating a logic app that would be sending notifications to the admin. So the reason why moving to serverless is beneficial is because it reduces the management overhead. It also allows to automatically scale in case the requests are high, and also will result in a low cost because of the pay-per-use pricing model. So for the triggers and bindings, the Azure function that will be used for order service, it will be an HTTP triggered function through a post method. Whenever there is an order that is placed, this would trigger this Azure function, and then the Azure function would have an output binding to an Azure service bus, because it would have to send the message to the queue. Also, for the AI service, in case there is a request to generate new AI content, this would be an HTTP triggered Azure durable function. So this would trigger the durable function, the HTTP request to generate AI content, and then this would kickstart the orchestrator, and the orchestrator would start different activities within that durable function to be able to generate the description of the text, the image, and save the generated images to a blob storage, and also send the generated text to be also stored as part of the product record. So for the other bindings, we also have an input binding for Cosmos DB and Service Bus. Here, for the makeline service, or for the makeline service, it would be consuming the message from the service bus. So it would have it would be triggered by the queue. So it would have an input binding to the service bus, but then the output binding, it would be to Cosmos DB, because the makeline service would be storing the orders to the Cosmos DB. So basically, the order service function is HTTP triggered and has an output binding to the service bus. The makeline service is queue triggered and has an output binding to Cosmos DB. AI service durable function is HTTP triggered and has a binding to Azure Blob Storage. For function chaining and orchestration, this would be used for the AI service, which would be converted into an Azure durable function, and the part in that would be used would be the function chaining, because the different activities, they would be dependent to each other. So the proposed model is to have a durable function which has an orchestrator that would take a product's metadata, and after taking the product's metadata, it would call on different activity functions. Like the first one could be responsible for generating product description, and the second one would be could be responsible for generating the product image. So each one of these activities would happen after the previous one, and the fourth one would save the image to a blob storage, while the last one would update the product record. So for handling long-running processes, this is concerning the AI service, which was converted to an Azure durable function. So the long-running processes, they will allow to perform automatic retries, and they will also allow to control the timeouts. So this will be used for AI image generation with fallback if it exceeds a time limit. Regarding the CI/CD deployment pipelines, the possible DevOps stack that I thought we would consider are GitHub Actions and Azure DevOps pipelines. And the reason why I chose this is because they could easily integrate with the code base, which is already in the GitHub repository. So either GitHub Actions or Azure DevOps, they could work well with the existing code base. And the steps of the pipeline would be first to build the microservices for the services which were not converted to serverless resources. And after the build, they would run tests on Azure function code, and then the pipeline would deploy the 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 Azure functions to the production environment, and after which it would monitor and collect logs and performance metrics of the serverless resources. For infrastructure as code, we could use Bicep or ARM templates to deploy this serverless infrastructure. For security monitoring and observability, the security option is to use managed identities for secure access to storage secrets, and also role-based access control to limit function permissions. For monitoring, we could use log analytics workspace and also implement custom queries using KQL to build alerts whenever there is a suspicious activity on the services. Also, we could use Azure Application Insights for live metrics. The comparison between logic apps and Azure functions, we are having most of the services converted to Azure functions, but one use case which I thought could benefit from logic app is the monitoring of the product inventory, where we could implement a scheduled product inventory check and make notifications to the administrator to let them know whether there is a shortage on the inventory. The Logic app could also be used to send teams notification whenever there is a high volume of orders or when there is an order fulfillment issue. So when you compare the Azure functions and Logic apps, is that for Logic apps, the flexibility is low, but also it's easy to implement even for non-developers, and it can also quickly integrate, especially with Teams for notifications. So on the other hand, Azure functions give you high code flexibility, but they are more intended for developers because they have a steep learning curve, and also they are based when the workflow needs to be highly customized. For messaging and event routing, we would replace the RabbitMQ with Azure Service Bus, because Azure Service Bus will provide more reliability and ordered message delivery, and also Azure Event Grid for lightweight eventing and, for example, image ready notification. The trade-offs are that the RabbitMQ is self-managed and flexible, but Service Bus is fully managed, but it is more secure and durable, and it can easily integrate with cloud-native applications. Also, Event Grid is best for a fan-out event distribution. To conclude, the serverless best practices, we applied R to use small purpose-driven Azure functions like for order service and make client service, and also bind to queues, blobs, and database using a declarative approach, and also is to monitor for cold starts or use premium plan if it is needed, meaning that whenever we think that the function is not going to be used a lot, we would need to monitor for these cold starts or opt for a premium plan, and then implement security using managed identity and key vault. So the outcome is that we will have a reduced operational overhead, and we also improve the scalability and agility. We could easily respond to high volumes of requests and orders, and also we have an enhanced observability and cost efficiency. Observability through monitoring, and cost efficiency because of the pay per use pricing model. Thank you.